So rates of change. So look at this table here. So I'm just doing your homework with you as usual. What was the average rate of change of the annual sales in millions of a product? So in other words, let's make sure this table's making, so you guys have the same thing right on your notes there, right? So that means in 1998, the sales was 127 million, I guess. Next year, 99, it's 172, 2000, 207, et cetera, et cetera. So what was the average rate of change between 2001 and 2002?
15 million.
Yeah, and good. How you coming up with that, Dalton?
I just subtract, well, what you could do is just subtract 247 from and 232.
Exactly. Perfect. Yeah, does that make sense? Because they're just asking us, from 2001 to 2002, what was the change? Change means subtraction, doesn't it? So if you subtract those two, would you say it is? Yeah, 15, huh? So 15 million is the change in that year. That was in 1 year, wasn't it? From 2001 to 2002. So that was the change in sales during 1 year. Now, next part, how about from 2001 all the way to 2006? So what are we going to do on that one? Yeah, so whenever you talk about change, you have to take, what you have to do is you have to take, it's basically a slope formula, isn't it? We have to take the final minus the start, over the number of years. Why? Because they're asking how many dollars per year. So in other words, the final sale, like in 2006, their sales were 207,000. Subtract what they started at in 2001, 232. If you subtract that, somebody got that in their calculator? What is that?
25.
What is it?
Negative 25.
Thank you. Negative 25. Yeah, the sales dropped 25 million, huh? You with me on that? So from 2001 to 2006, it went down from 232 down to 207. That's a drop, isn't it? That's a drop of 25 million. So notice you always do the final minus the starting amount, right? The last minus the starting one. That way you get the minus 25. But that was over how many years? How many years did it take for that $25 million drop? That was 5 years, huh? Because it went from 2001 to 2006. That's 5 years. So over a period of 5 years, divide by 5 here, huh? So over a period of 5 years, on average, they dropped 25 million. So how much is that per year? Yeah, divide by 5, huh? Minus 25 divided by 5. That's a $5 million drop, negative 5 per year. So negative 5 millions of dollars per year. That makes sense what we're doing there? We're just looking at the change over those 5 years. They dropped 25 million divided by 5 years. That's a drop of 5 million per year. Right? Because if you did 5 times 5, 5 million every year for 5 years, that'd be the $25 million drop. What's that? Yeah, we did. Well, on A, that was only 1 year. So on part A, I didn't need to, you could divide by 1, but that wouldn't change anything. Yeah, so A was easier because they only gave me 1 year. Whereas in B, they gave me 5 years, so I needed to divide by 5. All right. Now, how about part B? Find the average rate of change. Now they're giving me another function, and they want me to find average rate of change. Do you see how we just found average rate of change? We did a difference of y values over a difference of x values. Do you see it? In other words, this is y2. Let me change this up. This is y2 and this is y1. Meaning that's the these are like x values and y values in a table. This is the y2 value. This is the y1 value. This is the x2 value. This is the x1 value. That's what we really just did. That's how you find how much something changes. You're saying, what's the change in y? What's y2 minus y1? Final y minus initial y. And on the bottom, x2 minus x1 would be the difference in years. 2006 minus 2001 gives us that 5 years that we had on the bottom. So I'm making more formal what we just did kind of casually. Does that make sense? So let me go and let me exactly do it now. What is it? Minus 3x cubed minus 1. Let me go here where we have some more room. So I'm going to do number 2 right here. So y equals minus 3x cubed minus 1 from x equals, where was it? I don't even remember. Here, so how do we do this? So basically, and they're asking us average rate of change. Average rate of change is the same thing as slope. It's slope. It's steepness of the line. So in other words, it's going to be y2 minus y1 over x2 minus x1. So that'd be a good thing to put on your 3x5 card right there for the exam we take next Tuesday. So right there, difference of y's over difference. Whenever they say average rate of change, that's the same thing as slope. And so you just take y. Now, what do we mean by y2 and y1? Well, let's start with the bottom. What are the x2 and x1? This is x1, right? And this is x2. First x value, second x value. We good so far? That's just like the 2 different years, 2001, 2006. So we go, okay. So we take the x2, that'd be this one, 3, subtract, and then the x1, negative 2. Going to have the double negatives, going to add thing, right? So we're going to get 5 down there in the bottom, aren't we? Does everybody see that? It's going to be 5. So, why is that 5? What's going on here? Because here's 0, here's negative 1, negative 2, and here's 3. How far is it from negative 2 all the way to 3? 1, 2, 3, 4, 5. That's why that bottom is going to be 5. Does everybody see what we're doing down there? We're finding how far from one x value to the other by subtracting those. All right. Now on the top, what are we going to do on the top? How do we find y2? What does that mean, y2? Well, these are the y values. You've got to take that formula, bless you, and you've got to plug in the 3. Let me make this more clear with like this. So you got to plug in the 3 there. Subtract. I'm going to have to move this over so we have room. Subtract, and then you've got to do the same formula again. This time plug in negative 2. This formula and this formula, and you got to put parentheses around them. There we go. Do you see what I'm doing there? I know that can look very confusing. You see what I did is I just took the y formula right here, and it's right there, and it's right there. This is the y2. This is the y1. It's the y formula with the different x values plugged in. See how this x value is plugged in right there? And this x value is plugged in right there? That's what we're doing. So now let's compute that. Let's figure out what that comes out to be. So what do we have? So I'm going to work out this top up here. It's going to be minus 3. 3 cubed, use your calculator. 27 minus 1. The other one, minus 3 times minus 2 cubed, is minus 8. The bottom is 3 plus 2. So what do we get? So just use your calculator. This is going to be minus 81, minus 82, I think. Isn't that right? subtract, and the other part is 24 minus 1, 23 over 5. And that gives us minus 105 divided by 5. Isn't that minus 21? And that's our answer. Because that was not simple. So number 3 says, again, average rate of change. And so when you see the words average rate of change, you think slope. That's what slope is. It's how fast something is changing. So, all right, so what is it going to be? y2 minus y1 over x2 minus x1. They give us the function on number 3. They say g of x equals 5x cubed plus 2 over x to the 4th. And they say on the interval, -3 to +3. All right. So is this making sense so far? So how do we do this? So do you realize these are the two x? This is x1 and x2. And then, so I would start with the bottom. I think it's easy to start with the middle. So on the bottom, you're supposed to put what? x2 first, a subtraction symbol, and then x1, huh? So I'll grab x2 first, which is the 3, a subtraction symbol, and then the x1. Everybody good so far? So I just grabbed x2, subtract x1. x2, subtract x1. Because I'm just following that formula. You can put that formula right on your 3x5 card for the exam in a week, so you won't have to have it memorized. You just look over at it. My son just took an exam today that the teacher allowed him to use a 3x5 card, a math exam. He came back to my office afterwards, and he said, I was so glad I had that card. It was great. I just looked on that card, and there was what I needed. So put on the card that formula, and you just grab that. Now, what do you do on the top? We're going to plug into this formula, first the 3, and put that all right here, and then the -3, and put that all right here with a big minus sign in between, and we'll put parentheses around the whole things. Is that making sense? That's the y2 minus y1 deal. It really means you just plug into the function. Whatever function they gave you. What do you plug in? The exact two x values you have down below. So the x2 will plug in, that'll become y2. And then this, which is x1, right? x2, x1, plug in, that'll become y1. That's what we do. So you just plug in to that function. So I go, okay, here's the function right over here. So 5, when I come to x, I go 3 cubed plus 2 over 3 to the 4th. Oh, and then the -3 will come in the second part. It will be over here. And so that one, this one will be 5 times -3 cubed plus 2 over -3 to the 4th. Like that. Guys, just use your calculator and just get decimals. I'll do it with you and show you what I'm getting. Yeah, just crank this thing out with decimals. So what I'm getting then, so take 5 times 3 to, let me bring it down here so you can see it better. 5 times 3 to the 3rd power. So that's going to become, well, I'm just going to work out that whole thing there. I'm getting 135.0246914 for that first part. You guys able to get that? So let me show you what I did. Let me bring this over here. This is 5 times 3 to the 3rd power. The power button on different calculators, the power button will be the up arrow, or maybe it'll be the X to the Y. It's one of those two. So that's how you do 5 times 3 to the third plus 2 divided by 3 to the fourth. Again, either the up arrow or the x to the y equals, and I'm getting 135.024, blah, 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 blah. And then for the second part, I'm getting something different. I'm getting minus 134.975, blah, 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 331, all over 3 plus 3, which is 6. 45? Yeah, the answer should be exactly 45. The top comes out exactly 270. Exactly 270 on that. To explain here. You see how this right here, I stopped? There's really more decimals. So if you stop, you're not going to get the exact answer. So if you type in exactly what I have there, it won't come out exactly to 270, and therefore not 45 exactly when you divide by 6.
So how many decimal places over did you go?
I think it'll be fine. I think the program will be totally fine. With like if you type in 45, remember you got to divide by 6 at the end. So whatever you do, you got to divide by 6. So it should be. So if you got 45.000 with a little bit, I think it'll take it. But better than that, how do you do exact? You just type in exactly what's up there with parentheses and everything, rather than writing. I probably shouldn't have written these intermediate results. I'm just trying to help you get going. But better than writing these down and all that, is just type in exactly what's there. And it'll come out exactly. And then obviously it'll come out exactly 45. But the trick is, there's a couple of tricks in using your calculator. You have to remember to hit equals at this. So let me write down the exact keystrokes and see if that can be of any help to you. So here's exactly, well, every calculator is a little different, but here's generally what you would do. You go you have to put parentheses around the numerator, and then go 5 times 3 to the third plus 2 divided by 3 to the fourth, parenthesis. Oh, yeah, no, we need, yeah, I'll show you. Minus, parenthesis, 5, and then for the minus 3, you do have to put parentheses around a minus sign, to the 3, plus 2 divided by minus 3 to the fourth, parenthesis. Then you have to hit equals or enter before you divide by the denominator. That's super important. Is everybody hearing me on that? I hope I'm not doing the Charlie Brown teacher right now, the 1, 1, 1, 1, 1, 1. Am I coming in? Don't miss this point. You got to hit equals at the end of the numerator. If you don't, it'll only divide the last chunk, this chunk right here, by whatever comes after the divide. You want it to divide everything by the 6, right? So you've got to hit equals when you're done with the top, and that'll tell it, calculate the whole top for me, please, calculator. And it'll give you 270. And then you go divide by, and you know the bottom is 6, right? Because it's 3 plus 3, 6, right? The double negative is add. Divide by 6, then hit equals again. You should get the answer 45 exactly. So that should be the exact keystrokes you want to put in. 4 says again, average rate of change for the function f of x equals 7x squared minus 4 on the interval 1, comma b. So that function on the interval. So what do we do? Same thing. Whenever they say average rate of change, we use the slope formula, which is y2 minus y1 over x2 minus x1. Difference of y's over difference of x's, rise over run, they call it. Okay, and so I'll bring that down here. And that's going to be, now we start with the bottom. This time there's going to be letters, so they're going to want a formula in the end with letters. So what's the x1 and the x2 are right there, aren't they? x1 and x2. So put those down first, b minus 1. Top, we're going to take this function, 7x squared minus 4, right? But we're going to plug in the b, 7b squared minus 4, right? Parentheses around it. Subtract. And then same function again. Remember how we always do the y2 and the y1? We always do the same function, right? Both places, we take our function, 7x squared minus 4, and we plug in the b, and then the 1 is going to plug in. All right, so let's plug it in. So 7 times 1 squared minus 4. Is that making sense?
Does it matter what order you put it in, since one is...
Actually, because the x1 is whichever one comes first, and the x2 is whichever one comes second. And then we reverse that down there, because like it says x2 minus x1. Yeah, good question. Actually, technically, if you reverse both the top and the bottom, it's okay. Maybe that's more information than you wanted. Just as long as you just follow that order, you'll be good.
Okay.
Yeah, don't switch them. It'll be good. Is that good so far? See how that's exactly the same as what we did on the last two, except we're using a letter this time instead of numbers. Okay, now we're not going to be able to just use our calculator and get a number answer because we have letters involved. So we're going to just have to work out the formula. So what is it on the top? It's going to just be 7b squared minus 4. Subtract. Now, 7 times 1 squared. What's 7 times 1 squared?
1.
So 1 squared is 1, and then times the 7 is the 7, minus 4, so that's just going to be 3, isn't it? Over b minus 1, like that. Okay, and now, what can we do on the top? Let's remove the parentheses. So 7b squared minus 4 minus 3. If you lose $4 and lose $3, you lost $7, yeah. To there. Good so far. Good question. Good question. Yeah, what do you guys think? No. Dalton says no. Why not, Dalton?
Because it's the b's with the -1, so it's a package deal.
Yes. Right, remember the Costco package deal thing? Right? Pluses and minuses glue things together in algebra, which means you can't break the package. Yeah, so good question. Because of that minus 1, the b and the minus 1 are like stuck together, aren't they? Pluses and minuses glue things, and which means you can only cancel them if you buy the whole package, like shopping at Costco. Right? You buy the whole package, you can't buy individual. So with pluses and minuses. Okay, so we can't cancel out the b's, but you're right, you're thinking in the right direction. We do want to cancel some stuff. We can't just cancel the b's, but what can we do? Remember these from our review stuff? Lajeunesse? Yeah, and how am I going to simplify?
Take out the 7.
Yeah, good. You see what Lajeunesse seeing? We need to factor that top. Remember, that's how we get around the Costco problem. We factor. So, yeah, in the top, you see how they both have a 7? So take out a 7, and what is that going to leave inside?
B squared minus 1.
Yeah, b squared minus 1. Right, because that 7 could just distribute. We'd be right back where we were. Now, we still can't quite cancel. We still cannot cancel this b with that b squared or part of it or anything because they're still packaged. You know, it's all or nothing, and they're not quite exactly the same. They're a little different with that b squared, but there's one more step, huh? What do we do with b squared minus 1?
Factor it again.
Factor it again, and what is it? What does b squared minus 1 become?
B plus 1, B minus 1.
Exactly, difference of squares. Remember, b plus 1, b minus 1? Exactly. So we do that. I'm running out of room. I'll bring it up here. So that's going to be b plus 1, b minus 1 over the b minus 1. Remember that from our review days of factoring b squared minus 1. And now we can shop at Costco because we can buy the whole package. Right? The b minus 1 can now cancel. We're buying the whole package, so that's okay. So what are we left with? 7 parentheses b plus 1. I don't know if they want you to leave the parentheses or not. It's on our exam, it's going to be multiple choice, so it's fine either way. I'll show it though. Boom and a boom. This will be 7b plus 7. I'll just say or. Either one of those is technically right. Sorry. You read my writing right there? both are right. I don't know if the Canvas system will take them both. I think it will, but I'm not 100% sure. So both of those are the right answer. They're just different forms of the right answer. They're both good on that. To number 5, I'm going to go back because we got to see the graph. So here is number 5. We have a graph for us. And use the graph to evaluate the following. The average rate of change of f from 0 to 4. So same kind of question, same words. Average rate of change again. And what have we said that average rate of change always means? Let's go back, look at what we just did. So what is average rate of change always? Slope. Every time it's slope, which is y2 minus y1 over x2 minus x1. Average rate of change is fancy words for slope. How fast something changes is a slope. It's a fraction. Have you 10? Let me go back here to our question while I talk. If I say 5, I can grade 5 papers per hour. That's a fraction, isn't it? So a rate is always a fraction, which is a slope. If you can solve 10 homework problems per hour, that's also a fraction. How fast you do something is always a fraction. It's a rate, it's a slope. They're all one and the same thing. So when you see rate, just think, oh, that's how fast, and that's always a slope. It's a fraction, it's a slope. Okay, so getting back to the problem. So then how am I going to do it? I know this is a slope question. And what is slope equal? y2 minus y1 over x2 minus x1. Same formula we've been using. But now on a graph. How am I going to do it on a graph? Let's start with the bottom, like we have been. Right? Here's my two x values. Which one am I going to put in the front of this subtraction of x values on the bottom? Who comes first? Which one, down here, this is x1 and x2, right? Tracking with me? We always just grab the two x values and go x1, x2. So first we're supposed to put x2 according to the formula. So who's coming first?
4.
The 4, and then the 0. Good so far? So that means x equals 0 and x equals 4. That's my x1, x2. Now, what are my y2 and y1 values? How am I going to find those? On the graph, exactly. So where do I go exactly on the graph? So let's go for the at x equals 0. So here's the x-axis. Here's 0. There's the point on the graph, huh? That point is over 0 up 3, isn't it? That's an x value of 0 going with a y value of 3. And what's my other one? The other one is x value 4. Here's the point at an x value of 4. Over 4, up 5. That's another x value and a y value. You guys tracking with me? So this first point is x1, y1. The second point is x2, y2 on the graph. First point, second point. All right, so on the top, I'm supposed to take y2. Which one's y2? The 5. Minus the y1, 3. And we get 2 over 4. What do we do with that fraction? Reduce it, yeah. Divide by 2, top and bottom. 1/2 is the answer. So average rate of change, a rate is always a slope. Just find the x1, y1, x2, y2. Does everybody see why I found those two particular points? Because they told me x value 0 and x value 4. So I grabbed the dots at an x value of 0 and an x value of 4. Questions on that one? I'm going to try that one. Same kind of thing. Find the average rate between 0 and 5. So write the slope formula. Find the two dots on the graph they're talking about. So what are the x1 and the x2 on this question? 0 and 5, exactly. So this is our x1. This is our x2. So go to the graph, find the x1 and the x2. So same formula. All right, I'm going to jump in. Looks like you guys are good. So yeah, so the first x value is 0. So here's 0. It's this dot right here, huh? Over 0 up 1, that's the x1, y1. And the second is 5, so that'd be this dot right here. That's over 5 up 3. That's the x2, y2. So then we go to our slope formula. And it's going to have, now remember there's subtraction symbols top and bottom. That's in addition, bless you, to anything with negative signs. All right, so at the bottom, x2 minus x1, that's x2, x1, 5 minus 0 over y2 minus y1, 3 minus 1. So yeah, 2/5 it is. Those are better than those other messy ones we were doing, huh? When you see average rate of change, we do slope, don't we? Because how fast something changes is always a fraction. It's a slope. So y2 minus y1 over x2 minus x1. So give it a try. It's going to be, well, what's the x1? Make sure you're on track here first. So what's x1? Yeah, it's 1. It's right here, huh? x1. And what's x2? Yeah, it's that whole kind of strange 1 plus h thing. It's actually something they do in calculus. They're kind of getting you ready. It's part of the difference quotient, the derivative. Anyway, you'll see it later in calculus if you head that way. But see what you can do. They're setting you up for that. Same thing we did in the last few. Y'all seeing that? All right, so I'll start with the bottom again. What is the x2? First comes x2. That is 1 plus h. 1 plus h, and then subtract. And then the x1, which is 1. So that part's not bad. That's the friendly part. But on the top, it is not so user-friendly, is it? On the top, we're going to have to, remember what we do on the top? We plug into the function, don't we? So in fact, maybe this would be easier. Maybe this is more helpful. How about this? Just write this thing twice, but then go back and erase the x and plug in the x values from the bottom. So just write it twice. How about that? That's all we're really doing. We're just subtracting the function twice. That's what it means by y values. You'll get used to this more and more as you move up the line of math. Y values are always function values. Whenever they have y values on a graph or a formula like this, it's the same as function values. So y values are function values, okay? So I wrote down the function twice, but then I've got to erase this x in both cases and plug in the x value. What's the first x value? 1 plus h. Let me change the color. 1 plus h plugged in right there. And then the other spot, 1. So I put that right there. I put this right there. Does that make sense? That's all we're doing on every one of these. We're just subtracting the function values. Those are y values twice on the top, but plugging in the various x's. Okay, now that's a big mess, isn't it? What are we going to do with that? So I'm assuming you got here and then kind of can get stuck here easily, huh? 1 over h plus 12. I just added the 1 and the 11 there. And then minus 1/12. What happens on the bottom? What's 1 plus h minus 1 if we just gather all that stuff? 1 plus h minus 1 on the bottom?
H.
Just h, huh? Yeah, the 1 and the minus 1 are just going to cancel. Are we good to there so far? Questions to this point. Now what do we do is the real question, huh? This is a big mess. Fractions over fractions. How do we deal with it? How do we handle fractions over fractions? Well, there's a couple of different ways. I'm trying to think what would be the easiest here. Probably, I'm just going to multiply top and bottom. I'm going to do exactly what we did in the review. I don't know if you remember the review when we did fractions over fractions.
By H, right?
Well, by every denominator, every little denominator involved in the problem. So what are all the little denominators involved? What do I mean by little denominators? I mean this little denominator, right? The little bars. See how there's a little bar here and a little bar here? I'm not talking about the major bar. I'm talking about the two little bars and the denominators under those two little bars. So we have an h plus 12. Remember, that's a glued together Costco package. We can't separate the 12 and the h, right? Plus and minus is glue. So h plus 12 and separate 12. Now, what about the bottom? Well, it's h over 1 really, isn't it? It really doesn't have a little denominator, does it? So he doesn't contribute anything. So remember what you do with fractions over fractions, you take all the little denominators and you multiply every term, top and bottom, by all of them. Do you remember that? These are messy from the review. So that means I'm going to multiply by 12 times h plus 12, and 12 times h plus 12, and 12 times h plus 12. I'm not changing anything because I'm doing the same thing to the top and the bottom of the overall fraction, aren't I? All the terms on the top and the bottom, I treat it exactly the same. If you take a fraction, do the same thing top and bottom. You're not changing anything. It'll just look different when you're done. Right? That good so far? Now these are really over 1. Over 1. So what's going to happen? Maybe it'd be better if I squish this one in on the left instead. 12h plus 12 over 1. So what's going to happen now? These are going to cancel, aren't they? That's why we're doing it, because we want this stuff to cancel. What's left over in this piece?
12.
Just 12 minus. And what happens here now? The 12s cancel, and we're left with 1 times h plus 12. Good there. So see, I just cross-cancel and multiply whatever's left over. And that minus 1's going to distribute through those parentheses in a minute. Just try not to do too many things at once. On the bottom, does anything cancel? No, it's just got a 1. Nothing's going to cancel there. So what are they going to do? They're just going to all go together. You could just leave them like that. I'm going to write 12h, h plus 12. If you wrote h12, that's okay too. The order doesn't really matter. Just h12 looks funny. We don't usually write it that way, but it's fine. h12, 12h, whatever. Basically, I did nothing on the bottom. I just brought it down. I changed the order for looks' sake, but nothing really important happened. One more step. On the top, this minus 1 needs to distribute. You're going to get minus h minus 12. Does everybody see what happened?
So the bottom is 12h parentheses h plus 12.
Yeah, 12h, parentheses h plus 12. Right. Exactly, Faith, yeah. So it's good. So everybody see what happened, before I go forward again, everybody see what I did on this last step. Right, I took the two little denominators, the things that were under little bars, I just put them together and multiplied every term, top and bottom, by that, and then I cross-canceled. See how this is already nicer? It's a regular fraction now instead of fractions over fractions, because that gets rid of the extra fractions. So just think that way. When you've got all these extra fractions, you're getting rid of them. And how do you get rid of them? You multiply everybody by them, and they just cancel away. Okay, so then one more step. So I'll bring it over here. What are we going to get? 12 minus h minus 12 over 12h. h plus 12. Last step, 12 minus 12 cancels. Minus h. I keep saying last step. This problem will never end. So we get to there. There's actually one other thing, isn't there? And then it really will end. I promise. What's that? We actually don't have to. You can leave that. Can I cancel these h's? Or can I not? What about the Costco thing? Is it okay to cancel? Daniel says yes. Is it okay? So what do I mean by the Costco thing? Glue. Is anything plus or minus together? Do you see glue between any two things? Any pluses or minuses? I mean, other than, this. So I can't break those up. But is there glue between this 12 and this h? Or no? There's no glue. It's just shopping at Save Mart. You can buy just one. We can totally cancel it, can't we? It is. Daniel's right. We can totally just cancel right there. Just boom. Right? See how that's different? Because there's nothing glued together. The pluses and the minuses glue them together. We don't have any of that. So it's good. So I'm kind of running out of room terribly. What's left is the answer. So can I squeeze it in? I don't know where to squeeze it in. So our answer then, what's left on the top when everything cancels? Good job. -1, exactly, over 12 h plus 12. We really are done. That was quite a lot of steps, wasn't it? Terrible one. 10 minutes till break. All right, so for the graph below, is that increasing? So it gives a little piece of a graph. Is that increasing or decreasing? What do you think?
Increasing.
Is it increasing? So if I'm climbing that mountain, there I am, climbing that mountain. So am I increasing, going up, or going down?
You'll be going above.
Yeah, right. Good, Faith. Everybody see, I'm asking kind of a silly question. Faith's right. That'd be like getting on the side of a mountain, like that's the side of a mountain, saying, hey, is this mountain going up or down? Well, yeah, it depends which way you go, right? It goes up and down. What a kind of a silly question. Right, so really it goes, if you go to the right, I did that purposely just to make you think, but it goes both ways. So what do they mean? It goes up to the right, it goes down to the left. What do they mean? Is it going up or going down, increasing or decreasing? They actually do mean something. Do you know which way they mean? They have a particular direction in mind. Because otherwise it would always be both answers.
Increasing.
Yeah, because they want you to go to the right. We always mean as we go to the right. Otherwise it'd be both answers, huh? Yeah, so in math we always mean to the right. As you go to the right, yeah, you guys are right. It's increasing. So whenever they ask those questions, remember it's as you go to the right, which is positive x direction. That's why they do it that way. So it's going up. That one's increasing as you go to the right. Okay, good. Another graph, number 9. So how about this? And now they're asking us what intervals is this graph increasing and decreasing on? So if you're riding this roller coaster, I'm going to try my best to, there we go. Mr. Heron's artistic skills coming out again. All right, I'm riding that roller coaster. And so in what sections am I going down, decreasing, and what sections am I going up? And they mean, whenever they say intervals, they mean x values, the x-axis. So it looks, and they're assuming arrows in both these, meaning they're assuming forever, even though they don't show the arrow, they're assuming you understand the graph goes up and left forever, down and right forever. Okay, so therefore, what you're going down all the way to there, huh? So what x value does that look like it is? So I'm doing the very bottom here. So I'm doing this, right? So I'm going down all the way to there, and then after that I'm going up all the way to this peak. It's really from valley to peak where it changes from going down to going up, doesn't it? Right? Then right here, then I'll be going up in this section, and then I'll be going to right there, and then I'll be going down in this section, won't I? So this is down, up, down. So what are the x values? So the x values up to here. What's that spot look like it is? 2.5, negative 2.5. Yeah, that's what I'm guessing too. So negative 2.5. So all of this zone forever to the left up to negative 2.5 is a going down zone. Do you see that? It's this part of the graph, isn't it? So how do we say that as an interval? Remember how intervals work? Intervals are always left edge, comma, right edge. Parentheses or brackets, as the case may be. For these kind of intervals, it'll be all parentheses. I'll explain why in a second. So left edge, comma, right edge. So for this first green chunk, this first descent in the roller coaster here, this first going down part, that goes from a left edge of what's forever left? Negative infinity, right? Forever right is positive infinity, forever left is negative. So negative infinity up to negative 2.5. Everybody see that on the x-axis? From negative infinity to negative 2.5. That's the first section. And now from here all the way to there, the graph is going up. You're climbing in that x zone. So what's that x zone? From where to where? My graph's getting so scribbled up. Can you tell where that's at anymore? So this is negative 2.5 to 1. And that's, did I just put it on the wrong line? I did. You guys got to tell me when I do that. Notice how they put increasing on the top here? And decreasing. I got to switch that up, huh? So that should be down here. This should be negative. So the decreasing, the going down, is negative infinity to negative 2.5. The increasing, the going up, is negative 2.5 to 1. You guys tracking with me on the x-axis? This zone right here from negative 2.5 to 1. And then finally, the last section is going down. And that's what x does. That's decreasing. That's going to go down here. That's decreasing from an x value. What's up? Yeah, it's decreasing forever. It starts right here and then goes forever. Huh? Where does it start? 1 and then goes forever to infinity on that. Does that make sense? From 1 to infinity, it's also decreasing. So on the left edge and the right edge, it's going down as we go to the right. Down as we go to the right. And in the middle, it's going up as we go to the right. We're always going from left to right. Always parentheses, no brackets on those. Remember what brackets mean? Brackets mean you're straight on the number. Why wouldn't we want to use brackets? Well, because right at like 1, right there at the peak, as you're at the very top, are you going up or down? Right at the very top. Are you going up or down? Well, neither. You're frozen right at the top, right? It's the peak. That's why we don't want to include any of those endpoints. It's all parentheses. Dalton, do you want to?
And we don't add the...
All right, number 10, another graph. Consider the function to the right, blah, blah, blah. The function has a blank of blank, and it's talking about the minimum. If you click on when you're doing the homework, that bar will give you the options of minimum or maximum. So look at that little upside down U-shaped thing. Does he have this, we're talking about this point right here, huh? Is this point right up there, is that a minimum, right here, or a maximum? Yeah, because it's the highest point in his little vicinity, isn't he? That's a little maximum. So that's what they want you to say. He has a maximum of, and then they want you to do the value, at x equals, let's start with the x. I think that's more obvious. What's the x, for this dot right here, what's the x value he's at? Negative, because this is the x-axis, right? Good job, negative 3. And here they want the y value. When they say of something, they want the y value. What's the y value at that dot? 1. Yeah, the y value is 1. He has a maximum height of 1 at x equals negative 3. And then they're going to say, okay, where's the function increasing? They want an interval again. Can you write that interval? Remember, it's as you move from left to right. So you're right here on the roller coaster, moving to the right. So you're going up in that first section and then down in the second, huh? Right? That's like the beginning of a roller coaster ride where you climb the hill right at the top and then take the big descent. So we're going up in the first section and then down in the second. So remember how intervals work. Left edge, comma, right edge with parentheses. So what's the left edge? We're talking about this section right here. That's the going up section. And we're talking about the x-axis. So if I look at the x-axis, it's that section of the x-axis, isn't it? So what's the left edge of that section? Negative infinity up to negative 3. Does everybody see that? On the x-axis. So we're saying, let me erase some of this stuff. We're saying where on from negative 3, all these values, huh? We're saying from negative infinity up to negative 3 on the x-axis is that climbing zone.
This is the test of the State Center Community College.
So, again, right here, this is negative infinity to negative 3. Okay, and where's it? And that's where it's increasing. Where's it decreasing? Negative 3 to forever to the right, huh? Negative 3 to infinity. Are we good there? All right, so that was 10. Let's go to 11. So number 11 is showing that graph. They're saying find the absolute max and the absolute minimum. So we can all see the maximum is right there, isn't it? That's the highest point. That's the max. So what are the coordinates of that dot? Remember x and y coordinates?
0, 4.
0, 4, exactly. Is that making sense there? So that's the max, 0, 4. And then what's the minimum? Right here? And what's the coordinates of that point? 3, negative 5. Like that. Good there? Just want you to find the max and the min. Okay, so the function has, so this one, the function has a maximum of what at x? So this time they want us to do the x and the y separately. See how the format's a little different? This won't be a problem on the actual exam because it's multiple choice. But they want separate. So, there's a maximum you can see right there. So that's a maximum height. Here they want a height. What's the maximum height there? 1. At x equals, what's the x value there? 3. At x equals 3. Is that good? And then the next one, here is a minimum. Okay, and what's the minimum height? Yeah, -1, right? That's it, -1. At x equals, yeah, is that 5? 5. They can't hardly see it. 5, yeah. Good so far? Now, where is the function increasing? Yes, again, that's the roller coaster as we go from left to right. When are we going up? We're going up in this section, and we're going up in this section, aren't we? Those two sections, as you go from left to right, we're going uphill, aren't we? So, yeah, so how do we say the interval? Remember, it's always the portion of the x-axis. So we're saying this part of the x-axis up to there, huh? And then we're going to say this part of the x-axis to there. Those sections of the x-axis, can you see that yellow color very well? Those sections of the x-axis, let me erase that, are the increasing sections, right? All of this up to here, and from here to there. So how do you say that? -infinity to 3. Yeah, because remember, it's left edge, right edge for intervals. So this is -infinity to 3, and then 5 to infinity. Huh? There is a u. They do want a u between. I think Dalton was asking about that, and he's totally right. They want a u between those. I know. I looked at the thing during the break. So they want -infinity up to 3, and then from 5 to infinity. Left edge, right edge, left edge, right edge. And then where is it decreasing? Where's it going down? Well, in between, huh? From 3 to 5. From 3 to 5, it's going down.
Would they be brackets?
No, all parentheses. All the intervals are always parentheses. And then finally, what's the domain? It's been a little bit. Do you remember what domain is? Domain is like the width, like how far left and how far right does the graph go. Well, they're leaving off the arrows, but there really should be arrows, you know, on the ends there. So that graph actually goes, this graph goes down and left forever. And the graph goes up and right forever. So really it's going to get forever wide, isn't it? It goes forever to the left and forever to the right. So the domain, -infinity to infinity. Domain is the sideways coverage. And range is how far down and how far up it goes. Well, again, same thing. -infinity goes down forever and up forever. This graph goes left and right forever, up and down forever, doesn't it? Because of those arrows on the ends. And there's all the questions on that one.